So hello everyone, I'm going to illustrate how to build a non-inverting amplifier with a gain of 2, and we will build this on the breadboard, and we will inject a signal, a sinusoid signal, using the function generator. Then after that we will display it on the oscilloscope, the input signal and the output signal. So first, let's draw the op-amp. This is our op-amp, okay, with a negative and positive. And for a non-inverting amplifier. So you can see here that we will have, for non-inverting amplifier, we put the input signal at the positive, okay? So we will have here the signal itself, the input, and we will have a feedback here. Feedback resistance and resistance. So we have the output, the input, and we have here F and I. So to have a closed loop gain of 2, basically we have to have 1 plus RF over R should be equal to 2. So from this relationship, which basically is equal to V output over V input, we can see that from here we can see that RF should equal to R, so that I can have a closed loop gain of or equal to 2. So from circuit point of view, we can see that the circuit itself, we have LM, we are using amplifier LM 358. So we have here the layout for the chip, we have here the notch. So we have here 4 terminals. And basically they are, we have in this chip we have 2 op-amp operational amplifiers. So we have here V output 1, we have here the inverting or V1, then we have V1, the positive non-inverting terminal, and we have here ground. Then we have here the VCC. Because we are applying AC signal which has positive and negative sides, we are going to make our ground to be a negative VCC. And here I'm going to have, this one is 5 volt, and this terminal we're going to have negative 5 volt. Okay? So for the circuit, as we can see here, we can see that we have to put the RF between the output and the negative terminal, which here, which that means we have to have here a resistance, basically connecting these two, and then this RF. Then we have this resistance with ground. So let's see first how we are going to get this +5 and -5. As we said, we have a voltage power supply. That has 3 voltage power supplies that we have here in the lab. We have here V1, V2, and V3. So we have 2 terminals, basically. We will put in, let's use V1 and V2, and we will make them, both of them, 5 volt. 5 volt, 5 volt. So how to connect them to have +5, -5, and ground? So basically, we will put them in series. Let's have analogy of batteries, alkaline battery, which is in series with another one. So basically, we will have here, let's assume this is plus or negative 5 volt, plus or negative 5 volt. And we need to have the ground to be in the middle point. We will make this one the ground connection. So the voltage between the top of this terminal to the ground is +5, and between this ground to the bottom of this terminal it's -5. Okay, so in this case, if you have this power supply, it will be connected like the following. So we have here the negative terminal of this one connected to the positive terminal. So we will have a cable connecting these two, and this one is going to be the ground. And we will have here this wire is going to represent the -5 volt, and this one is going to represent the 5 volt. So let's make different color. So I make this one a red color by 5 volt, and this one a black one with a -5 volt. So let's connect this to the circuit. You can see that basically this -5 is going to be connected here, this terminal, and the -5 will jump here, it will be connected here in the ground, and this one is going to be connected to the ground inside the circuit, which basically, let's say for this resistance, is between the negative terminal and the ground. So let's draw this resistance from the negative terminal. So connect one here, and this is R, and going to be connected to the ground. Okay, and we will apply our input voltage to the positive terminal. So our input terminal, or the input is going to come from a function generator. So this is a power supply. Let's have our function generator. So for this one, has different signals. Sinusoid, has square wave, has triangle, sawtooth, different signals. So basically, we will take one of them, one input here, and we will connect it here. So let's connect for this function generator the positive here, and the negative terminal is going to be on the ground side. So this one should be connected to the same ground. This ground, which is this ground. The last thing that we need to do here is to put the oscilloscope to visualize the input signal, this signal, and the output signal that comes out of here. So let's make the oscilloscope. So let's assume this oscilloscope. It has a screen to show you the signals. So basically this is so it has two terminals. Let's say this we have channel 1 and channel 2. We have two terminals, negative and positive. and we will visualize here two signals. So let's first connect this one, channel 1 on the input. So the input, this is the input. So we'll get this one, it will be connected here. And then the negative part, it will be connected to the ground. Then the second one, so at this point we will see a signal for the input itself. Then if we connect it to channel 2 with the output, the line of the output, and this one to the ground, so we will see another signal which basically is going to show us the output itself, which is the output, two different lines. So this is the setup that we are going to have. The circuit on the breadboard, the power supply to create the plus and negative amplifier board with the ground in the middle. Then we have the function generator to inject the input signal, and we will select the sine wave, okay, to here, and basically we will have this oscilloscope to visualize the input signal and the output. Just make sure here that here we need RF equal to R, and we have a gain of 2. We have a maximum of 5, which means if the output signal cannot be more than the VCC, so V output should be less or equal to VCC. Okay? This is very important. Or let's say this is supposed to be V output should be bigger than or equal to minus VCC, and should be less than VCC. Okay? So you have to select the amplitude of your sinusoid carefully so that you can have amplification using the op-amp. Okay? So this is the representation, the circuit representation, and right now we will go to do the circuit itself. Thank you.